This spinning spectacle we're all part of, this silent dance the Earth performs, is a marvel of cosmic proportions. Our home planet, Earth, pirouettes on its axis, an imaginary line that runs through the North and South poles. This rotation is what gives us the familiar rhythm of day melting into night, then waking up to a new dawn. It's a dance that Earth has been performing for over 4.5 billion years, a ballet so precise that it's the very reason we have a sense of time. This rotation isn't a random occurrence, far from it. It's not as if the planets woke up one day and decided to start twirling. No, this rotation is the result of specific scientific phenomena, laws of physics that have been at play since the dawn of our universe. You see, the Earth isn't just spinning in place, it's also orbiting the sun while it spins, like a top, spinning while moving in a circle. This combination of spinning and orbiting is what gives us our year and our seasons. It's a carefully choreographed dance with the Earth as the star performer and the sun as the audience, and fascinatingly, the speed of Earth's rotation isn't constant. It varies depending on where you are on the planet. At the equator, the Earth is spinning fastest, while at the poles it barely moves. It's like the Earth is a giant spinning top, with different parts moving at different speeds. What's more, the Earth's spin isn't perfect, it wobbles just a tiny bit, a phenomenon known as axial precession. But this wobble is enough to cause significant changes in our planet's climate over thousands of years. So what sets our planet in motion and keeps it spinning? What's driving this cosmic dance? Let's delve deeper. To understand the Earth's rotation, we have to travel back in time to the birth of our solar system. Picture that. About 4.5 billion years ago, our solar system was just a cloud of dust and gas. This cloud, or nebula, was likely the aftermath of a supernova explosion, the violent death of a star. The gravitational pull from the remnants of this star brought the cloud's particles closer together, causing the nebula to collapse under its own gravity, forming a flat, spinning disk. At the center of this disk, the sun was born, and the remaining material began to form the planets, asteroids, and comets we know today. The Earth, like other planets, formed from this spinning disk of gas and dust. This is the key point, my friends. The Earth was born spinning. But why does it continue to spin? Here's where the principle of conservation of angular momentum comes into play. In layman's terms, objects in motion want to stay in motion. A spinning ice skater, for instance, continues to spin until they actively slow themselves down. Similarly, our Earth, once set spinning, wants to keep spinning. The Earth's rotation is simply the continuation of the initial spinning motion it had when it was formed from that spinning disk of gas and dust. There's no significant friction in space to slow down this spin, so the Earth, much like that ice skater, continues its spin, albeit at a much grander scale. Interesting, isn't it? Now, you might be wondering about the speed of this rotation. Why isn't it spinning more rapidly, or conversely, why hasn't it stopped altogether? Well, the speed of Earth's rotation isn't constant. It's been slowing down, but very, very gradually, over billions of years. But don't worry, it's not about to stop anytime soon. So the Earth spins because it was born spinning and has kept up the momentum. And that, ladies and gentlemen, is the birth of rotation. But if you think the Earth's rotation is constant, think again. Just like a well-spun top eventually slows down, so too does our planet. The Earth's rotation isn't a fixed speed, but gradually slows over time due to gravitational interactions with the moon and the sun. So let's dive into the nitty-gritty of how this works. Picture the Earth and Moon as two dancers twirling around each other in a cosmic ballet. The Moon's gravitational pull tugs on the Earth, causing a slight bulge toward the Moon. This bulge in turn pulls back on the Moon, creating a sort of gravitational tug-of-war. The same game of cosmic tug-of-war is played with the Sun, albeit on a much larger scale due to the Sun's immense size and gravitational pull. These gravitational interactions generate a kind of friction, acting like a brake on the Earth's rotation, causing it to slow down little by little. But how much is the Earth slowing down? Well, it's not something you'd notice in your lifetime, or even in the lifespan of humanity for that matter. The rate of deceleration is incredibly slow, about 2 milliseconds per century. To put that into perspective, that's roughly equivalent to the time it takes for a hummingbird to beat its wings once. This minuscule slowing of Earth's rotation means that our days are getting longer. Not in a way that you'd need to reset your watch, but over millions of years, the difference adds up. Scientists have found evidence in ancient corals and tree rings that a day on Earth hundreds of millions of years ago was only about 22 hours long. So the next time you wish there were more hours in a day, remember that your wish is slowly, ever so slowly coming true, but don't start planning what to do with your extra time just yet. At the current rate of slowing, it will take about 140 million years for our day to increase by just 1 minute. In fact, a day on Earth wasn't always 24 hours long. So we've established that the Earth rotates, but what does this mean for us? Well, let's dive into it. The Earth's rotation is a key player in creating the conditions for life as we know it. Consider our climate. The Earth's spin on its axis, coupled with its tilt, creates a range of climates across the globe. This is why we have tropical rainforests at the equator, deserts in the subtropics, and polar ice caps at the poles. The alternation between warmth and cold, wet and dry, is a fundamental aspect of our planet's character. It shapes the diversity of ecosystems and species that inhabit the Earth. Now, let's talk about wind and ocean currents. Have you ever wondered what's behind the constant movement of air and water around the globe? That's right, it's the Earth's rotation. This rotation sets up a complex system of atmospheric and oceanic circulation patterns known as wind and ocean currents. These currents distribute heat and moisture around the globe, playing a crucial role in regulating our planet's temperature and weather patterns. And let's not forget about the most noticeable effect of Earth's rotation, the cycle of day and night. This 24-hour rhythm is so ingrained in our lives that we often take it for granted. Yet it's this very cycle that drives the rhythms of life on Earth. Plants photosynthesize during the day and rest at night. Animals have evolved different behaviors and adaptations based on whether they're active during the day or night. Even our human bodies have internal clocks aligned with this cycle, governing everything from sleep to metabolism. So, you see, the Earth's rotation is not just a cosmic ballet. It's the engine that drives the rhythms of life, the flow of winds and oceans, and the diversity of climates on our planet. It's a silent, yet powerful force, shaping our world and everything that lives in it. Without the Earth's rotation, life as we know it would be quite different. So there you have it, the why and how of Earth's rotation. We've journeyed together through the eons, tracing the roots of our planet's rotation back to the chaos of the solar system's formation. Like a spinning top set in motion by the hands of cosmic forces, Earth began its eternal pirouette. We learned how this rotation is not constant, but a waltz in slow decrescendo, gradually losing momentum due to the gravitational tugging of the moon and sun. Yet, this deceleration is so snail-paced that it takes millions of years for us to notice any significant change. And most importantly, we've seen how this spin of ours is not just a showy twirl in space. It's a life-giving dance that creates our days and nights, drives the winds and ocean currents, and makes our blue marble a habitable haven in the vast cosmic arena.